All right, let's take a look at example 3. Let f of x be x times x minus 6 to the power of 1/3. Find the intervals in which f is increasing, decreasing, and find the local extremes. Now note here, what we have is a product, so we are going to use the product rule. We are going to take the derivative, we will keep the x, times the derivative of this x minus 6 to the 1/3. So that is 1/3 to the negative 2/3. Keep the inside function times the derivative of the inside function, which is 1, plus derivative of x, and then keep the x minus 6 to the 1/3. We will recognize that both factors here, both terms, have x minus 6. So we'll factor that out. The largest power of x minus 6 we can factor out is the smaller one, so that is the negative 2/3. When we factor that out from the first term, we are left with a 1/3 x times 1, which is just 1/3 x, plus, and then when we factor it out here, we're left with a 1 and an x minus 6 to the 3/3. 3/3 minus 2/3 make the 1/3. Note, this is the same as x minus 6 to the 2/3 in the denominator because of the negative power, 1/3 x plus, note 3/3 is a power of 1, so this does nothing to this expression, and times 1 does nothing to the expression. So that's what we have from here. We want to remove this fraction, so we'll multiply everything by 3. Same on the bottom. We get x plus 3x minus 18 over 3 times x minus 6 to the 2/3. Simplifying, combining like terms, x plus 3x makes 4x minus 18 over 3 times x minus 6 to the 2/3. Now, we will find our critical points. So we know f prime of x is equal to 0 when the numerator is equal to 0. That is, when 4x is equal to 18, or when x is equal to 18/4 or 9/2. We know that f prime of x is d and e when the denominator is 0. And we can see very easily that that is when x is 6. So we will perform our sign test around these critical points. So we will mark 6, and 9/2. We'll make this one 9/2, which is 4.5, and we'll make this one 6. Remember, we are sign testing the derivative, so that is this expression here is going to get sign tested. We're going to plug in a number less than 9/2. How about 0? If I put a 0 in on the top, I get 4 times 0 minus 18, which is a negative. If I plug in 0 on the bottom, I get 0 minus 6, which is a negative 6, but because of this power of 2, it becomes positive. This power of 2 will actually make any number come out positive, except for 6, of course. So a negative divided by a positive is a negative. Now, if I pick a number here between 4.5 and 6, say 5. 4 times 5 is 20, minus 18 is a positive. We know the bottom is naturally positive, so positive divided by a positive is a positive. Now, bigger than 6, say 7. 4 times 7, 28, minus 18, positive. The bottom is positive, 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 positive. All right, now let's try to answer our question. We know f is increasing on 9/2 to, well, a infinity because f prime of x is positive. We know f is decreasing on negative infinity to 9/2 because f prime is negative. Now, we do know that we have local extreme here at 9/2. So we know f has a local, goes down, then up, minimum at x equals 9/2. And we can see that right here. So we are decreasing until 9/2, and then we increase, and we do notice at 6, we have that vertical tangent, but we do not stop increasing at any point. It just gets nice and vertical. All right, that's example 3. Let's take a look at example 4. Last one. Let f of x be x plus 2 sine of x on the interval 0 to 2 pi. Find the local maximum and minimum values. So we'll start by taking the derivative. The derivative of x is 1. The derivative of 2 sine x is plus 2 cosine x. We will go ahead and set this equal to 0. This then becomes 2 cosine x is equal to negative 1. Dividing by 2 gives us cosine of x is equal to negative 1/2. Using our unit circle, we know negative 1/2 will lead to this point and this point in our interval 0 to 2 pi. So that is x is equal to 2 pi over 3, and x is equal to, we got 1/3, 2/3, 3/3, 4/3, 4 pi over 3. So these are our x values that we're going to sign test. So we'll perform our sign test. Place 2 pi over 3. We're going to cut off at 0 because of our closed interval, and cut off at 2 pi, and place our 2 pi over 3 and 4 pi over 3 critical points. We are going to pick a number between 0 and 2 pi over 3. How about we use pi over 4? Okay, if we place pi over 4 into our derivative, we get 1 plus 2 cosine of pi over 4. Cosine of pi over 4 is root 2 over 2, so we will get a positive. Now let's pick a number between 2 pi over 3 and 4 pi over 3. How about pi? We have 1 plus 2 cosine of pi. Cosine of pi is negative 1. So we have 1 plus 2 times negative 1. That's going to result in a negative. Let's pick a number bigger than 4 pi over 3. How about we use, I don't know, what do we think? 4 pi over 3 is here. How about we use 3 pi over 2? So 3 pi over 2. So 1 plus 2 cosine of 3 pi over 2 is 0. 1 plus 2 times 0 is a positive. Okay, so we get f is increasing on 0 to 2 pi over 3 union 4 pi over 3 to 2 pi. F is decreasing on 2 pi over 3 to 4 pi over 3. Note the increase because f prime is positive, decrease because f prime is negative, and then f has a local max at x equals 2 pi over 3. So right here it goes up and then down, and f has a local minimum here we go down then up at x equals 4 pi over 3. Now, looking back at the graph, we can see that that's reasonable. We increase until 2 pi over 3, and then we decrease until 4 pi over 3, and then we increase again. Local maximum here at 2 pi over 3, and a local minimum at 4 pi over 3. All right, I want you to go ahead and attempt some of the 4.3 homework set. Do note the 4.3 homework set is for 4.3a, 4.3b, and 4.3c. So you will not be able to solve the full set until all 3 lessons have been finished. So please only complete the parts of the lesson that we have learned. Hold off on the others.